This is section 1-1 entitled Discretionary and Essential Expenses. And there's a quote here that kind of sets the stage for this whole section. And it says, "A bargain ain't a bargain unless it's something you need." Okay? The objectives of this particular section are to be able to identify the difference between essential and discretionary expenses, to determine the mean, median, and mode of a data set, and to create and interpret a frequency distribution table. These are some key terms in this section. First of these is gross income. This is income prior to deductions, okay? Next is disposable income. This is income after deductions. And basically, deductions in both of these cases are primarily taxes. Then we have an essential expense. This is an expense for a required item. You need this item. You cannot live without it. For example, food, okay? That would be an essential expense. A discretionary expense is expense for something not required. For example, you don't need to take and have a boat, for example. That's not something that is required. That is a discretionary expense. Now, in addition, there are some math terms, and these may be familiar to you already, but let's review them anyway. The first of these terms is mean. This is basically another word for average, where you take the total sum of all the elements and divide by the number of elements, and that gives you the average. The next is median. This is the middle element. But what's key here is before you can figure out what the middle element is, you must set the data in order from smallest to largest. Once you have done that, then you find the middle term, and that is the median. And then lastly, the term is mode, which is another word for most. Now, with mode, we can have one mode, multiple modes, or no mode. If all the elements in the data set occur the same number of times, whether it's once, twice, or 3 times, so long as each element occurs the same number of times, there's no mode. There's one mode if one particular element occurs more frequently than any others. Okay? And you can also have multiple modes where you have 2 or more elements occurring the same number of times, but more than some of the other elements in the set. So you can have no modes, one mode, or multiple modes. So let's look at an example. Elena knows her morning cup of coffee is most definitely a discretionary expense. Okay, this is not something that she absolutely has to have. She pays $2.75 for a 9-ounce cup and was wondering if that is a typical price, okay? On Monday, she asked 6 of her coworkers what they paid for a 9-ounce cup of coffee. Their costs per cup were $2.85, $2.15, $1.95, $3, $2.05, and $2.40. How can Elena compare her expense with those of her coworkers? What she can do is determine the mean or average of the costs that the coworkers spend. So if we add up all these values, $2.85, $2.15, $1.95, $3, $2.05, $2.40, and divide by 6, we come out with an average of $2.40. Now, compare this with what Elena spends, which is $2.75. So therefore, we can see that she is paying too much for her coffee, that her coffee is more than the average of what her coworkers spend. Now, what if I take the information about coffee prices that was in example 1, and let's say I want to represent the formula for the mean price using a compact notation, rather than writing out all the numbers and adding them and dividing. What could I do to make that a little bit simpler and more compact? Basically, we'd use something like this. This is a summation notation, okay? And we're saying the sum from I equals 1 to 6 of x sub I. So basically add up, or the sum, all the elements and divide by the number of elements, which is where we multiply by 1/6. So let's look at example 3. Anthony wants to make a discretionary purchase of a basic laptop computer. He checks the prices of a particular make and model listed by 7 different vendors on a shopping comparison website. He found these prices $850, $798, $2,400, $790, $836, $700, and $780. He computes the mean as $1,022. This number doesn't seem to be a good representation of the data. How can he find a better representation? Well, let's say he puts the numbers in order from the smallest to the largest. All right? And so if we take and look at the smallest and we eliminate the bottom and the top, the next to the bottom to the next to the top, the next one to the next one, what do we end up with? We end up with 798, and this is the median. Now, this is a better representation of what the prices of these laptops are. So now, let's suppose that in example 3, Anthony had only found the first 6 laptop prices when he conducted his online search. Determine the median of these prices. Well, the first 6 are listed here. If we get rid of the lowest and the highest, the next to the lowest, the next to the highest, we've got 2 numbers here. We don't come out with a single number for a median. We got 798 and 836. Well, in order to find the median, what you have to do is find the average of these two. So if we add these two, divide by 2, we come out with the median now is 817. All right, let's look at example 5. Transportation expenses to and from work are considered essential expenses. Charlie Jane would like to reduce this essential expense by biking to work rather than taking her car. She found 30 different ads, both online and in print, for the make and model of bicycle she wants to purchase. She made a list of the prices in ascending order. Notice we're going from lowest to the highest. She wants to analyze the prices, but is having trouble because there are so many numbers. How can she organize these prices in a helpful format? Okay, so yes, you could add all these up and divide by, but that can get to be very cumbersome. So let's see a better way of looking at this. If she took the values and created something called a frequency table, it would make life a lot easier for her. So we've got 3 columns here. The first column is the price of the bike. The second column is the frequency, or the number of times that price occurred. And then the third column is the product of those 2 numbers. So here's all her prices from $250 to $350. Notice $250 occurred 2 times, $275 occurred 4 times, $280 once, $290 2, $310 5, $315 6, $320 1, $325 3, $330 1, $335 1, $340 1, $350 3. You add them up, she had 30 different prices, okay? Now, if we multiply the price times the frequency in column 3, we get all these numbers here. So 250 times 2 is 500, 275 times 4 is 1100, 280 times 1 is 280, and on down to the bottom. And then if we add all these numbers up, we get 9,250. Now, if I take the 9,250 and divide it by 30, I'll get approximately 308. That's the mean or average of this data. As you can see, it's a lot easier to take and do it this way to come up with the average than it would be to add up every single one of these 30 numbers and divide by 30. Okay? So this is another way, by using a frequency table, to come up with the mean or the average.